Okay, hello. Good evening, guys. Welcome back to our June week 4. All right, happy Thursday to y'all. All right, this is the last week of June. All right, so yeah, quick reminder. If you have any video requests you want to do, please do it before this Sunday. All right, because after this Sunday, when we enter July, you are not allowed to request for new videos, June videos anymore. All right, so please make sure you request your video before this Sunday if you miss any of this month's class. Right, quick reminder. Right, anyway, I believe not everyone is here. Yeah, late as usual. Anyway, let's go into our chapter 4. We are supposed to go into chapter 5 today, right? Yes, Rebecca, is your internet okay? What does it take so long for you to join? Anyway, we are in chapter 4. I know we finished chapter 4 last week, right? But we are going to finish the exercise first. Oops, sorry. Before we move on to chapter 5. And yes, we are going to enter chapter 5 today. Okay, we are going to enter chapter 5 today, which is a very simple chapter. All right, so I think I stopped in question 9, right? Last week, this is page 15. We are still in chapter 4. We are still in chapter 4. I have not finished all the exercises yet, and I decide to repeat, not to say repeat, I decide to finish all these exercises before I move to chapter 5. All right, because chapter 5 is a really simple chapter. I don't want to rush into that chapter because you can handle it just fine. All right, yes, Chuan Xing, hello. Jin Nao, hello. All right, anyway, let's go into chapter question 9. Okay, question 9. This is page 15. So if we have done it, you let me know because I'm not too sure whether we have done it or not. So the figure below shows the apparatus setup used by a student to compare the reactivity of hydrogen with tin metal and aluminum metal. All right, so as you remember, oxygen is the girl. All right, so now tin is married to oxygen. You already know this. Tin is married to oxygen. And then this hydrogen is trying to come in and rampas the wife. Okay, remember what is rampas wife? I talked about this last week. Okay, anything that is lower than carbon, I can use carbon to take their wife away, and this process is called reduction or penurunan. Okay, anyway, so hydrogen and tin oxide. So who will win? So we have Mesti, Ada, Zaka, Fantastic, Supaya. So your C and H is here. All right, C and H is here. So my hydrogen is here. Tin is here. All right, yes, Kaipo, hello. So tin is here. So hydrogen is more lengthized than tin, right? It's better looking than tin, right? So hydrogen can rampas tin's wife away. That means hydrogen can rampas oxygen away from tin. So this is called reduction, because tin is less good looking than tin. Hydrogen. All right, so A1 suggests one way to produce hydrogen gas in the laboratory. All right, so how do you make hydrogen gas? You can either use electrolysis of water. You remember what is this? Do you remember what is this? You learned this in Form 2 actually. You use electric to split water into hydrogen and oxygen. Remember? You learned this in Form 2. Hello? Don't tell me you forgot. So this is called electrolysis IA. Or if you say, sir, is there another method? I don't want to use this can. You can actually use metal. Okay, you can say metal reacts with acid. All right, when metal and acid they react, they produce hydrogen gas also, which is in our this part over here. Are there? You see, zinc plus the acid, you get hydrogen. So you might say, sir, which is better? Okay, either way is fine. Right, so fine both. So logam bertindak balas dengan acid. You just need one lah, guys. You just need one. Guys, I know this is very boring. This is getting repetitive, isn't it? Wow, sir, this Rampas wife thing, you have to talk about that for 3 weeks, man. Yes, this is the 3rd week already. I really hate to repeat this, but this is me trying to make you score. All right, I want you to do all these exercises so that I make sure you can score everything in this chapter, because it's really easy, right? It's really easy. So how do we dry the hydrogen gas produced? Right? Why do we need to dry this hydrogen gas? You see, when we produce hydrogen gas, this hydrogen gas has a little bit of water to it. All right, and we need to pass it through this thing called anhydrous calcium chloride to dry this thing, and then when it comes back here, now it's dry. You might say, sir, need to dry this thing, man. Why need to dry this thing, man? Because if you don't, this thing is going to explode. All right, if you don't react, you know, to get rid of the water, this thing will explode. So you can use something called anhydrous calcium chloride. Right, in English, sorry, in BM, this is called calcium chloride contact. You know what is this, guys? I told you this before already. This is the silica gel. You know, when you buy new shoes, there's a pack inside there that says do not eat. That's the calcium chloride. The thing will help you absorb water, absorb moisture. All right, anyway, B, state one precaution step that must be taken when conducting this experiment. Explain your answer. So what should be done? All right, as you know, hydrogen gas is very explosive. Do you still remember? When you put glowing wooden splinter into hydrogen, you will hear something. That is your pop sound. All right, pop sound. Hydrogen gas will give you pop sound because they are very explosive. They are very dangerous. So what must you do? Can you see a fire here? Can you see a fire here? That means any extra hydrogen gas, you must burn it off here. All right. So because the previous one, when we do the previous one, I see no fire here because there's no need to. But this one, you need fire here because if you don't use fire, if you don't burn off the hydrogen gas, this thing is going to explode. All right, so that's the precaution step that you must do. So what do? You must burn off excess hydrogen gas. Okay, membakar gas hydrogen berlebihan. You must burn off the remaining gases. All right, so why? So they need you to explain the answer. Okay, this is to prevent explosion. Untuk mengelakkan letupan. If I don't do this, this thing is going to explode, which is not a nice thing to happen lah. All right. Anyway, guys, are you still with me? Are you still with me? I know this is getting boring. I know, sir. You've been repeating this thing for 3 weeks already. I wanna pick some already. Yes, me too. Me too. Hey, you imagine every week I teach this thing 6 times. You know, I teach the same thing for 6 times. So imagine for 3 weeks, I've been repeating it for 3 weeks, and every week I need to repeat 6 times. You think I'm not bored, man? I'm actually very sick of this chapter already. So that's my point. I want to get through this as fast as I can. All right. Are you guys still with me? Hey, you can clearly see in this chat, goodness me. Wow, I can feel the boredom here. Even the chat is like, you know, dead quiet. Okay, hey guys, not my fault because this chapter memang is this boring one. Okay, you're holding on well. Thanks, Rebecca. Thanks for holding on. All right, anyway, this will finish real soon, right? I swear. All right, anyway, so the table shows the result obtained. So tin oxide and hydrogen, this thing will glow. Why? Because oxygen kena rampas by hydrogen already. What about this? What about this? You see, aluminum and hydrogen, anything is gonna happen. If you according to this chart, you see, aluminum is better looking than hydrogen. Aluminum is the lang zai one here, is the good looking one here. Doesn't glow, yes. So aluminium, hydrogen cannot take our wife away, because if you are married to someone so good looking, of course you won't follow this guy away. Right? So you can say no reaction, okay, or doesn't glow. Tiada tindak balas. Oops, sorry, tiada tindak balas. There's no reaction. Nothing is happening here. Because hydrogen is not as reactive, not as leng zai. Remember I said reactive means good looking, leng zai. Reactive is leng zai lah. So briefly explain why tin oxide glows very brightly. Why does it glow when heated with hydrogen gas? Because hydrogen took the wife away, right? How do you say take the wife away? The taking wife away process is called reduction. Okay, penurunan. So in this case, you say because hydrogen reduces tin oxide. Okay, please don't say take tin's wife away, because your teacher will go, huh? So hydrogen menurunkan tin oksida. Alright, the process is called reduction. So reduce. Menurunkan, penurunan. So it reduces this thing. So write an equation to show the reaction when tin is heated with hydrogen gas. So when tin oxide reacts with hydrogen, so what's going to happen? Oxygen will be taken away, right? So you will be left with tin. Tin is now left alone, right? Tin is now left alone, and then you have something called hydrogen oxide, right? Hydrogen oxide. All right, don't you find this thing very weird? Don't you find this thing very weird? You might say, sir, what is hydrogen oxide? Got such thing one, man? Actually, hydrogen oxide is water lah. Water lah, H2O hydrogen and oxygen ma. So water is hydrogen oxide lah. It's just a stupid name for water, right? So it's water. So you get tin and water. Okay, simple. So next, number 3. Predict the observation when aluminum oxide is heated with hydrogen gas. Okay, we have done it here already. Okay, we have done it here already. There's already no reaction. So explain your answer. Okay, why is it no reaction? Because aluminum is more reactive than hydrogen. Like I said, reactive means more leng zai lah. Aluminum is more leng zai than hydrogen. Lebih reactive. Alright, lebih reactive. Okay, can yes, Jiayu, hello. Good evening. Alright, we are in question 9, chapter 4. Guys, I really want to finish this as soon as I can. Okay, so please hang on. Please hang on. I hope you have your chapter 5 notes with you. I hope you guys have your chapter 5 notes with you, because I'm going to chapter 5 later. It's okay, as long as you're here. As long as you are here. Alright, are you a new student, or are you from Yuqing or Hanni's class? I've not seen you before, right? Sorry. I think I haven't seen your name before, right? Okay, anyway, so this is question 10. They already give you the good looking ranking chart. Alright, so you can actually do this yourself. So sodium oxide is reduced by carbon to sodium. So can carbon rampas the wife away? Reduce is taking the wife away, right? So can carbon take sodium's wife away? Sodium is number 2 here. Carbon is number 5. Do you think if I'm a number 5 guy, I can take away number 2's wife away? Of course not. So no reaction, because carbon is not as good looking. And then B, magnesium is more reactive than calcium. So magnesium is more reactive than calcium. Is magnesium more leng zai than calcium? Because reactive is leng zai, right? No, of course not. Because calcium is more good looking. Okay, it's more leng zai here. So C, copper reacts with oxygen to form copper oxide. That means copper will marry oxygen to become copper oxide. Yes, this one has nothing to do with rampas wife and whatnot. And then D, hydrogen cannot reduce zinc oxide to zinc. That means hydrogen cannot take zinc's wife away. Yes, this is true. Because zinc is very good looking, more good looking than hydrogen. So hydrogen cannot take his wife away. So correct lah. And then E, zinc and iron can be reduced by carbon, but not if using hydrogen. So is this correct? Is this correct? So zinc and iron is here. Okay, they say can be reduced by carbon. That means carbon can take their wife away. Yes, because carbon is better looking. But not hydrogen, because hydrogen cannot take their wife away. Yes, because hydrogen is not as good looking. So yeah, this is correct too. All right, so CDE is correct. Like I said, this whole chapter is about this ranking system. Okay, this good looking chart. It's the same question over and over again. All right, anyway, moving on. Let's look at question 11. Oh, this is our blast furnace. Hey, Minecraft, guys. Minecraft. So, P here. What are substances added in P? So, in P here, you add 3 things. All right, what do we add? Since you are trying to extract iron, right? We are going to add iron ore. Because you get iron from iron ore. Iron ore is the natural form. But we don't want that. We only want iron. So we put, this is the raw material. If you want to say iron oxide also can. Okay, but I'll write iron ore lah, biji besi. Okay, biji besi. And then next, what do we use to take the wife away? We use carbon. So carbon in real life, we call it coke. Okay, the form of carbon is called coke. And then we add one more thing. Actually, these 2 things, they are enough. Okay, it's already enough. But now we add one more thing. The thing is called limestone. Right, batu kapur. Why do we add limestone? Okay, let's go to question B. They want you to state the use of each substance. What's their use? Okay, why do we use iron ore? Why do we use iron ore? What's the function of iron ore? It contains iron. This is the thing we want. This is the thing we are trying to extract. Well, the point of you putting iron ore into this thing is so that we can get iron. This is the raw material. Okay, this is the raw material. We are trying to extract iron here. So the BM1 is mengandungi besi. This thing has iron. All right, then how about the coke? What's the function of the coke? Coke is carbon, right? Carbon's job is to take away iron's wife, right? So the job of carbon is to reduce iron oxide. Rampas wife, take away the wife, reduce carbon dioxide untuk menurunkan besi oksida. Trying to take the wife away. And then, of course, just now you're asking, sir, then what's the function of this limestone? Like I told you last week, limestone's job is to produce something called slag. Remember? Slag. What is this slag? Slag is this, we used to think that it's rubbish, but now we found out that slag can be used to make cement. Okay, cement as in the cement you use in construction. So the function of limestone is to produce cement. Untuk menghasilkan cement. Alright, so while you make iron, you can also make the raw material for cement. Okay, so that we'll use this in cement lah. So next, C, write the word equation for the formation of iron. So how do we get iron here? Like I said just now, you start with iron oxide, besi oksida. This is the iron ore. Guys, this is the iron ore. This is the raw material. And I have carbon and carbon monoxide here. You might say, so what got carbon monoxide? What got carbon monoxide one? Don't care. They have the same job, which is to take the oxygen away, to rampas the wife away. Now, when my wife kena rampas already, now it's left with iron, besi. And now you have carbon dioxide. So both of these, they are the same equation. Is yeah, there. Kok, there. Okay. Yes. Hey, Zachary, you're taking in BM, is it? You're writing it in BM, is it? Oh, I didn't know that. All right, anyway, so this is your iron. This is how we get pure iron. So now the iron will come out from here. This is how you get your raw iron, and we call it steel. Steel, as in galuli. Mandarin is called 钢铁的钢. The thing is called steel. All right, so that's your iron. So then name the substance that is tapped off. What is R? What is S? R is the slag. S is the iron. So this is the slag. This is the iron. C. Okay. Oh, wait, sorry. I think Zach, I misunderstood your question. Why is coke in BM called coke? Don't ask me why. Don't ask me why. BM is a very funny language. BM is a very funny language. That's the way they translate. Sometimes when I translate BM, it feels like BM is a very lazy language. All right. When they translate things, they just directly take it from English. Might as well you don't translate, right? This is why I say if you have the chance, guys. It's too late for you to switch anyway. But next year, because next year you're starting fresh again, you're in Form 4. If you feel like switching to English, I highly suggest you do so. Okay, why? Because next time, I've mentioned this a million times, if you are going to university, you are still going to write in English. So why not switch now, right? Make your life easier. So please switch to English. Okay, so you sooner or later you still have to switch one. So might as well you do it now or in Form 4. All right, anyway, so E, carbon is used to extract iron and tin from the ore. Can carbon be used to extract aluminium? Hiya, this one I mentioned so many times already lah. Aluminium is here. Can carbon take the wife away? No, because aluminium is too good looking, too like already. So these five good looking fellas, you cannot use carbon. You have to use electrolysis. Okay, electrolysis, that means use electric to break them lah, like this thing here. This one in your hey, I just mentioned that just now. So can it be used to extract aluminium? No. Okay, tidak. Explain your answer. Because aluminium is more lengthai, right? Because aluminium is more reactive. Like I said, reactive means lengthai lah. Okay, more reactive than carbon. Okay, in BM is lebih reactive daripada carbon lah. Okay, you write it yourself. So you can say aluminium. Sorry, carbon cannot rampas the wife away, right? So carbon cannot reduce aluminium oxide or aluminium ore. Tidak dapat menurunkan. This thing cannot reduce, that means to rampas the wife away. Carbon cannot rampas this wife away. Cannot. Because carbon is not good looking enough. There. So easy. Hey, as you realize, guys, I don't know whether you realize this. This chapter, you keep using the word reactive, and reduce. These are the two words that you keep using like non-stop. Isn't this repetitive? Right? Isn't this repetitive? It's very repetitive. So I don't want to, keep repeating the same thing. I feel like Astro now. Okay, because Astro, they keep repeating the same show. Right, anyway, so F, the water and air pollution caused by unplanned bauxite mining in Kuantan is uncontrollable. Your goodness me, I'm going to skip this. What are the side effects of unplanned mining to living things on Earth? Walao, guys, this is pollution. Please answer this yourself. This is in geography. Hello? Apakah kesan sampingan pelombongan? You go and refer to your geography textbook. Okay, I'm not going to mention here. So many things. Okay, kepupusan flora dan fauna. Okay, kemusnahan habitat. If you want me to repeat this for you, I'm gonna slap you seriously. All right. Anyway, question 12 we skip also because it's the same question again. This is the blast furnace. Anyway, let's go to question 13. All right, this will be the last question I wanna discuss. Okay, question 13. This is K-bar question. I want you to take note a little bit. This is a K-bar question. You know what's a K-bar question, right? Those so-called high order thinking question lah. Things that require you to think, not just answer them blindly. All right, so assume that a new element named rhenium was recently discovered. Imagine now they found a new element. Okay, let's not call it rhenium. Let's call it vibranium. Ooh, sounds cooler, isn't it? Okay, or unobtainium. You go watch Avatar. I think Avatar, the one is called unobtainium, right? Vibranium is the one in Marvel. Okay, you know Black Panther, his suit is made from vibranium. Okay, so-called the material from outer space or some shit. They are so strong, they use it to make the Captain America shield. Okay, fine, whatever. So you see, rhenium, they are recently discovered by scientists. Pure rhenium element was heated with zinc oxide and iron oxide separately, and the observations are shown. All right, so let's see what happens. When rhenium burn together with zinc, you see, no change. No change. What does it mean? That means rhenium cannot take zinc's wife away, right? Rhenium cannot take zinc's wife away, right? Because there's no change. The girl will say, hey, I marry someone so good looking already. Why would I want to follow you? You're so ugly. That means zinc is better looking than rhenium. Right? You see, this is the same concept. I'm just, thinking of another new element. So next, rhenium and iron oxide are now the mixture glows. There is a reaction. What does it mean? That means rhenium can take the wife away. Rhenium can rampas iron's wife. So that means rhenium is better looking than iron, isn't it? Okay, iron is Fe so rhenium is better looking than Fe, isn't it? So compare the reactivity of rhenium with zinc and iron. So how's the reactivity like? Of course, it is less reactive than zinc, less length than zinc, less reactive than zinc, but it is more reactive than iron. You see, it's better than iron. Iron is not so good looking. Rhenium is better looking. Okay, so in DM is kurang reactive daripada zinc, lebih reactive daripada besi. You write it yourself lah. So number two, A2, explain your answer in A1 based on observation in the table. So they want you to explain here. Why this one no reaction? Why this one got reaction? Why is this less reactive? Why is this more reactive? You can say rhenium. I'm just going to write R lah, guys. Okay, rhenium cannot. Rhenium cannot reduce zinc oxide, but can reduce iron oxide. Okay, rhenium tidak dapat menurunkan zinc oksida, tetapi boleh menurunkan besi oksida. That means R cannot rampas this wife away, but R can rampas this wife away. All right. So that means R is somewhere between zinc and Fe lah. So where is rhenium? So if we draw the thing out, Mesti, Other, Zaka, Fantastic. So your rhenium is around here. Rhenium is around here. Right, that means between zinc and Fe lah. It makes sense, right? Okay, it's between here, right? So B, scientists also found that rhenium is usually found in the form of rhenium oxide in the Earth's crust. Right, they exist in oxide also. That means they have a wife here. So based on your answer in A, suggest how rhenium can be extracted from its oxide. So how can you extract? All right, if rhenium is here, let's say rhenium is here, zinc and iron, if rhenium is here, so it is lower than carbon, right? Lower than carbon, right? So anything lower than carbon, we can use carbon to extract. There's no need for you to use electrolysis unless they are above here lah. But rhenium is here. Rhenium is here. So how can you use how can you extract rhenium? You can use reduction. Okay, the rampas wife lah, penurunan. We can use carbon to rampas the Y from rhenium, and rhenium now you get pure rhenium. All right, so reduction, penurunan. So explain your answer. Why can we use reduction? Okay, because rhenium is less lengzai than, oops, sorry, okay, less lengzai than carbon. Okay, so BM is kurang reactive. I'm just keeping my answer short here, guys. R is less good looking than carbon, so carbon can reduce rhenium oxide. Okay, boleh menurunkan rhenium oxida. They can reduce rhenium oxide. So if they can now they want the equation. Write an equation. So the equation would be rhenium oxide plus carbon. Carbon can take the wife away, right? So now you have pure rhenium and carbon dioxide. It's the same as iron. It's the same as iron. It's just another new imaginative element. Now we imagine something out, which is called rhenium. Not really possible, but it's just a very fun question. It's just a K-part question. All right, so this is how we get 4 marks. Really easy, right? Really, really easy, right? I hope you understand, guys. I hope you understand. If you have anything you don't understand, please type it in the chat. I will gladly explain it for you. But I believe by now you are already sick of this chapter. Okay? Yes, sir, we get it. Lengzai, not lengzai. Can rampas, cannot rampas. Yes, sir, we get it. I'm sure you're like this by now. Okay, that's why I say this chapter is not hard. Not hard at all. Right? So I believe, yeah, that's the end of the exercise. All right, so this is it for chapter 4. I am not going to repeat this in the short term. I'm not sure yet, but most likely not because this chapter is, it is what it is. It's a very straightforward chapter. There's really nothing, there's no point for me to repeat. All right, so if you can understand this, let's go into chapter 5. All right, let's go into chapter 5. If you are from physical class, I'm not sure whether you received this already, but if you're from online, if you're online class, then you should have received this by, I don't know, last month. Okay, last month, and some tutors, okay, I don't know where is Yuqing and Han Yi currently, but I assume that they are ahead of me already. Maybe they already entered this chapter. I'm a bit slow. Okay, I'm a bit slow. There's just too many things for me to say. All right, too many grandfather story to tell. All right, anyway, so let's look at chapter 5. Okay, this is also a very boring chapter. I'm sorry to say, but hey, good news. If you look at your chapter 4 notes, there are only 4 pages. You might say, why is it only 4 pages there? Because this is a very simple chapter. I can actually finish this in today. I can finish this by today, but there's no point. Okay, I'm gonna chill a little bit here because after last chapter, which is so intense, so many things to memorize, this chapter, on the other hand, is super simple. All right, super simple. What does it mean? Okay, let's look at this thermochemistry. This chapter is called thermochemistry. In BM, it's called thermokimia. What does it mean by thermo? Thermo means heat, harbor, panas, harbor. All right, so heat is thermo. Chemistry is chemistry lah. Chemistry is chemistry lah. Chemical reaction lah. That means this is a chapter to deal with chemical reaction and their heat. All right, chemical reaction and their heat, because all chemical reaction, they will do some kind of heat exchange. Either they will absorb heat or they will release heat. Right? Whenever you do chemical reaction, there will be temperature change. Right? It's either increase or decrease lah. Right? Any equation, any chemical reaction, you do any reaction, you will have some kind of heat change. All right, so which brings me to my next point. So our chemical reaction has 2 types. You have exothermic reaction, tindak balas exothermic, and you have endothermic reaction. All right, what does it mean? Just now I said, right, chemical reaction can make a temperature go up or temperature go down, right? If the chemical reaction make the temperature go up, that means I release heat to the surrounding, right? Listen guys, this is the main point. If the reaction release heat to the surrounding, okay, bebaskan haba, the surrounding will become hot. Hot. I throw heat one. All right. If I'm beside you, I give heat to you. You feel hot, right? So if the surrounding becomes hot, okay, this is what we call an exothermic reaction. What does it mean by exo? It's not the boy band. Every year when I say EXO, girls will get excited for no reason. Okay, this is not the boy band, guys. Okay, EXO means exit. Okay, EXO means exit. That means heat exit. Okay, heat exit. I bebaskan haba. I release heat to the surrounding. So the surrounding becomes hot lah. So that's the point, you see. Surrounding temperature increase. Suhu persekitaran meningkat. My surrounding becomes hot. Okay, for example, what is the example of exothermic? Very easy, burning lah. Burning lah. When you burn a piece of paper or whatever lah, let's just say you burn a piece of paper. When you burn paper, the surrounding becomes hot, right? I mean, any burning, your surrounding becomes hot lah. So exothermic lor. Right, exothermic lor. And then the other one, when the temperature goes down, when the surrounding becomes cold, this is called endothermic. Endo means enter lah. Just now exit is exo, right? Exit what? Now endo is enter. So heat will enter this thing. All right, this reaction will absorb heat. Now the surrounding becomes cold, right? When you're sitting in an aircon room, why do you feel cold? Because the aircon is absorbing your heat away. So now you feel cold. Right, so surrounding temperature decrease, suhu persekitaran menurun. There you go. All right, there you go. So it's a very simple. Hey, that's it lah. Do you know that's it? That's it about this chapter. You see, I finished this in like what, 10 minutes. Then you must say, sir, finished already. Then what about the rest? The rest of it, they are just examples. Okay, examples. Like I said, if I really want to finish this chapter, I can do it by today, but I'm not going to lah. I'm not going to lah. I know you guys are very tired back from your school, right? I believe these few weeks it's your co-curriculum, and you are dead tired from them. I know. Okay, I was your age once. Okay, your school just has some, countless of meaningless activities. Oh, your coco stopped already, Why stop, leh? Why stop? I thought just started only stop again. What reason? Why? Because many people kena COVID. Oh, exam. Oh, okay. Oh yeah, KK is having exam soon, right? Oh yeah. Now I remember. Oh yeah, KK is having exam soon, right? Oh, you guys are the weird ones. Yeah, now I remember. Okay. Okay. Hey, your exam is coming soon, guys. Make sure you study, Make sure you study, if you have anything you want to ask me, please do so. Oh, you're next week. Okay. All right, sure. Guys, a little bit of advice for your revision. Don't focus so much on the notes. Focus more on the exercise. All the exercise I've discussed with you read the exercise. Read the question, then read the answer. Read how I answer those questions, and you will score just fine. All right. Hey, our TDC exercise are all very difficult. If you can understand, you can do then your exam is like easy peasy already. Okay. Anyway, so moving on, let's go to our energy level diagram. Okay, this is very simple. So exothermic is releasing heat, right? So you see the energy level, it goes down. Okay, reactant and product, the energy goes down. Okay, what is reactant and product? If you go back to our form 4 exercise just now, all right, when you have reaction, you see this is the reaction, right? When these two react together, you get these two, right? So this side is the reactant, Okay, the left hand side is the reactant, the right hand side is the product. How to contact me? How to contact me? Yeah, sure. Guys, I'll put my phone in the chat. I'll put my phone in the chat. If anything you want to ask me, please feel free to do so. All right. If you have any question you want to ask, okay, you can WhatsApp me. I will answer you as soon as I can. All right. Anything lah. You want me to answer your relationship problem? I can also help you. Yeah, I'll try my best, lor. Okay. Even you say, can you answer sejarah for me? Okay. Hey, really got student go and come and ask me sejarah one, you know. Okay. I'm glad to help. I used to teach sejarah also. Okay. So if I can help, then I might. Okay. You see? Good this kind of teacher where to find. Okay, anyway, so our reactant and product so as you can see, the energy level drops. Energy level drops. Okay, where's the energy? The energy is released. It is released. Sudah dibebaskan. The energy released to surrounding already, so the energy level drop lor. Whereas your endo is the reverse lah. Energy level goes up because now I absorb heat. I suck heat from the surrounding, so I have more energy. Okay, I absorb. Menyerap haba. This one is membebaskan haba. Okay, so that's all lah. Really easy lah. Exo and endo. That's all that really is about this chapter. All right, so the next one this thermal equilibrium I don't want to talk about this. Okay, you can put a cross here. This thing I don't care. All right, I don't care because it's really not worth your time. What is thermal? Okay, if you really want to know what is thermal equilibrium, thermal means heat, haba, equilibrium means same, sama. What does it mean by thermal equilibrium? Means same heat lah. Same heat lah. What does it mean by same heat? All right. Sometimes when you're hot when the weather is really hot you put your face onto some metal, right? Ooh, nice. It has that cool feeling to it, right? Or if your floor is made from marble, right? Your house the floor is made from marble. You will just lie on the floor. When you lie on the floor, wow, nice. It feels so cold. Why? Because the floor is cold. Your body is hot. You are releasing heat to the floor. All right, you are releasing heat to the floor. And at some moment, maybe 10 minutes later, it doesn't feel so nice anymore because now the floor is also warm. Same temperature as you, in fact. Right? You are 37, the floor is also 37. Now you are feeling like, this is not so nice to sleep on anymore. You go and find another spot to sleep on. Right? So that's when you reach something called thermal equilibrium. You guys reach the same heat. Haba yang sama. Same heat. Same temperature. Everything same. That's why it doesn't feel so good anymore. Because it feels warm. Yeah. Not so nice anymore. Alright? So this is your thermal equilibrium. Anyway, you can kind of ignore this. Really not important. Because I say so. Because it really is not important. You will learn this in physics next time. Alright, anyway, about this chapter, you'll be doing a very stupid experiment. Alright? You'll be doing a very stupid experiment. Why do I say stupid? Because this is what you do. Your teacher will give you some sodium hydroxide. Okay, and then you put it into the water. What do you do now? You stir with the thermometer. So you stir. All right, at the beginning, maybe, okay, if I haven't add this thing, maybe the water is 27 degrees Celsius. Now, after adding sodium hydroxide, you stir, this thing will go up to 35. Okay, from 37 to 35. What does it mean? That means this thing becomes hotter, right? Surrounding becomes hotter, right? So this is an exothermic reaction. There, end of story. End of experiment. Lame as shit, I tell you. Okay, lame as shit, I tell you. This is a stupid experiment. This is for once, I really hope that your teacher doesn't let you do this because it's a waste of time. All right, what's there to see? What's there to see? It's just you stirring with the thermometer and read the thermometer. Okay, this thing increase. Okay, cool story, bro. There you go. This is the exact thing you get. Nothing else to see. No explosion, no flame, no nothing. You just see temperature increase. All right. And you know what's the worst part? To make this experiment really accurate, you have to switch off the fans. right? You have to stir this thing in heat. In a warm room, you have to stir this bloody thing and you have to switch off the fan. You know why? Because when you switch on the fan, the fan will just cool this thing down. Now the temperature is not accurate. So you have to switch off the bloody fan. Right? That's why I say this experiment, I pray hard that your teacher doesn't let you do, because it's basically pointless. All right? Because how do I know this? Because in university we did this. In my university, we did this bloody experiment. It's so damn freaking boring. And you have to switch off the fan. And the worst part, we have to wear that stupid lab coat. Okay, we have to wear that stupid lab coat. It makes us hot AF. So no point. This is a stupid experiment. All right, so exothermic is when the temperature increases. Maybe you start with 27. This thing goes up to 35. Yay! Heat release. Exothermic. Okay, and then ammonium chloride, maybe it goes from 27 to 21. Yay! Temperature drops, heat absorbed, endothermic. Then that's about it. That's about it. There's nothing fun here, right? If you expect some kind of explosion, you can forget it. It's not going to happen. All right. Anyway, okay, let's talk about some examples. Okay, before we end this. Before we end this class, before I end my torturing, okay, I hope you are still listening. I hope you are still listening. Okay, anyway, so exothermic, let's look at some examples of exothermic. Okay, what are some exothermic reaction? Number one, respiration. All right, when you do respiration, okay, guys, respiration is not breathing. I told you this in chapter 2 already. Respiration is when your cell release energy. All your body cell will do respiration and release heat. This is what makes you warm, right? Your body temperature is warm. You are 37 degrees. So this respiration will release heat to the surrounding. Now your body is warm. So respiration is an exothermic reaction. It gives out heat, right? There you go. Next, burning. When you burn something, it releases heat to the surrounding. Surrounding becomes hot. So burning is exothermic. Pretty lame, isn't it? All right, next, neutralization. I hope you still remember what is this. You learned this in Form 2, Chapter 6, when you add acid and alkali. Remember, when you add acid and alkali, this is called neutralization. BM is called perneutralan. Okay, perneutralan. So when you do neutralization, heat is released. All right, that means when you add acid and alkali, your cup will become hotter. Maybe just a bit. Guys, this one you don't get a lot. Neutralization, maybe you will get a 1 or 2 degree increase. Very small increase. But it's still exo. It's a very slow exo, but it's still exo. So that's your exothermic reaction. That's your neutralization. All right, next, thermite. Oh, this is interesting. Guys, this is interesting. All right. Are you guys interested in some World War II story? Are you guys interested in some sejarah? Okay, let's talk about sejarah. Okay, guys, I will not talk about some boring shit sejarah. Okay, let's talk about something interesting. Okay, you know what? By the way, do you know what is thermite? Do you know what is thermite? Thermite is a reaction of magnesium and barium peroxide. Okay, you might say, sir, what is this? You don't need to know. What you need to know is this is a very exothermic reaction. Very exothermic. What does it mean? It releases a lot of energy to the surrounding. In fact, it is so hot. Ooh, mango. Okay. In fact, it is so hot, this thing can reach up to 2000 something degrees Celsius. Okay, hey, you can actually make this at home. Okay, you can make this at home if you are good with chemistry. Hey, this thing is so damn hot. This thing can reach around, I don't know, 2000 something degrees, I think. Somewhere around there. Okay, are there around 2000 something 2000 something. Okay, is that nuclear? No, it's not nuclear. This is just thermite. Okay, so do you know what is this good for? If you want to burn through logs, let's say now you're breaking into a bank. You know, bank has this vault, right? It is made from steel. So how do you melt through that vault? Thermite. You just use thermite. And the best thing is, this thing is quiet. It's just burning. It's just a very exothermic burning. You don't hear anything. It's not like bomb where you get a loud bang. There's no banging here, no bang bang here. So this is just a very slow, it's just a burning. All right, so where do we use this? This thing is used to repair your railway. They are so hot, they can melt iron on the spot. All right, so let's say you want to repair railways. This is how you use thermite. Okay, there you see, they can melt railway because they are so hot, very exothermic. Okay, so you might say, sir, how is this thing related to sejarah? Okay, how is this thing related to sejarah? All right, so I don't know whether you guys are interested in World War II, because I am. I read a lot on World War II. All right, so if you read on World War II, oh wow, Yashwini, okay, now I have an interested audience already. All right, so if you study World War II history, you know that Nazi is the one that everybody was trying to bring down, right? Hitler's army. All right, so during the World War II, Hitler actually made a super weapon. Okay, that time there was no nuclear yet. Okay, he created something called a Gustav gun. Okay, this abomination is so freaking scary. It's basically a tank on rails. All right, imagine this thing. Imagine this thing, and you know how big the round is? How big the bullet is? The bullet is this freaking big. Okay, it's a freaking tank. Okay, it's a freaking tank. And if you look at the stats, you know what's the firing range? You know how far this thing can shoot? This thing can shoot up to 39,000 meters. Okay, 39,000 meters. Okay, you see, effective firing range 39,000 meters. And for those of you who are good in maths, 39,000 meters is 39 kilometers. 39 kilometers. Okay, so what is 39 kilometers? Basically, if this piece of abomination, if this gun is in KL, as in KL city center, I can fire to Shah Alam. I can reach Kota Kemuning with this thing. Okay, that's how far this thing can shoot. And you know what's the scary part? Hey, this thing is on rails, This thing is on a train track. Okay, this thing is built on a train track. That means this thing can move. All right, so imagine this thing is in action. How many people are going to die? All right, so this is the Gustav gun. And what happened to this Gustav? Okay, the lucky thing is, yes, Yashwini, thank you. Okay, so what happened to this thing? Fortunately, this thing did not went into action. This thing did not went into action. You know why? Because a group of spies, a group of allied spies, they actually infiltrated into Germany and they burn a hole through this thing. So what do they use? They use thermite. They use thermite and they burn a hole through the barrel. Can you see the long barrel? They burn a hole through the barrel. So this thing actually went out of service. All right, so thank God it happened. If it doesn't, then you imagine how many lives. Okay, wouldn't they repair it? Here's the thing. Okay, that's a very good question. You might say, sir, why can't Hitler just repair it? Because you see, during World War II, steel is something in short supply. Okay, steel is something in short supply because everyone, the Russians, okay, we call it the Soviets, the Americans, the British, they need steel for many things. They need to make guns. Okay, as in rifles. Every soldier need a rifle, right? They need steel to make rifles. They need steel to make tanks. They need steel to make ships. And they need steel to make planes. All right. If you read World War II history, if you read about Nazi, they are one of the country with the most airplane. All right. It's called the Luftwaffe. Luftwaffe is their air force. But of course, they are not as good as the British Air Force. The British Royal Air Force has the most planes among all the countries. All right, this is why Germany couldn't infiltrate Britain. They couldn't infiltrate Britain because they don't have enough planes. All right, hey, interesting stuff. You see, when people tell me, sir, sejarah is boring, I will say, how is this boring? Okay, I mean, you guys don't read World War II stuff lah, so Malaysian history is boring. Okay lah, where got? Lately they released a movie called Mat Kilau, right? Go and watch lah. The thing is about Malaysian history, leh. How he fought against the British, leh. The sejarah they teach in school is boring. I don't know about you lah, but I actually read up a lot on Malaysian history one, you know. Okay, Malaysia history, I read that too. I mean, all history is interesting. Oh, you watched it? Wow, that's nice. That's nice. I haven't got the chance to watch it yet. Right? So go and, if for those who are not really interested in Malaysian history, this movie might help. Okay, it's called Mat Kilau. It's a Malaysia production. Yeah, go and watch it. Don't watch like overseas movie all the time. Okay, give our Malaysia local production some support. All right. Anyway, so this is your termite. So next time, if you want to break into a bank, or you want to break into a rich man's house, and you see the house got a lot of lock, you know what to do lah. You just use termite. This thing can burn through anything. All right. I don't care whether the lock is made from steel or what. You have termite. If the termite is hot enough, this thing can melt through any lock you want. You see? This is how smart people do it. All right. Anyway, moving on. So next, freezing of water. When your water freeze into ice, the thing release heat to the surrounding lah. So when they release heat, this is exo law. They become zero law. And of course, next is your heat pack. I'm sure you know what is this, right? You know what is this heat pack, right? This heat pack, inside it actually contains something called sodium acetate. When you squeeze this thing will start to release heat. So this is exothermic lah. You use this thing for what? Okay, for your muscle cramps, for blood circulation, if you have period pain, this thing is very helpful. But the thing is, this thing is only one use. Okay, you use it once, you have to throw it away. So that's your heat pack. Okay, sodium acetate, exothermic reaction. Okay, next, sodium hydroxide. This is something what we call a drain cleaner. Okay, drain cleaner. Do you know what is this? Right, do you know what is this? There's heat flushing. Yeah, I know. I have one. Okay, you actually charge. You use USB cable to charge it and it will turn hot. Okay, I have one. Not because I have periods lah. It's because I have sore muscles all the time. Okay, because I train. All right. Anyway, so what is a drain cleaner? All right. So for those of you who are living with girls, if your house got a lot of girls with long hair, like your mom, your sisters, your whoever lah, I'm sure there's a freaking annoying problem. Yes, it's hair everywhere. Yes, exactly. So what if one day the hair got stuck in the drain, the water cannot flow down? What to do? Very easy. You just go to the hardware store, you go and tell them my longkang got hair stuck inside. What should I do? They will sell this thing called drain cleaner. So what does it do? When it's like a powder, when you throw it down to the drain, it's called sodium hydroxide. And when you add water, this thing is very exothermic. And this thing will heat up the whatever that's inside your drain lah. So it will melt your hair. It will melt the grease. It will melt the hair. So after a few hours later, you just let this thing soak there for a few hours, and then after that, you just flush it with your water. The thing just works like a dream again. So this is your drain cleaner. All right, exothermic again. All right, so the last one, that would be your glow stick. Okay, glow stick. Inside there is hydrogen peroxide and this thing called phenyl oxalate ester. You say, sir, what is this? Don't care. You just have to know when you break this thing is exothermic, and they will release light, heat and light. They will release heat and light, so it makes it sort of like a emergency lighting source lah. There they use it in diving, right? Glow sticks. They use it in there. This is the thing lah. You go party, they will have this thing lah. There exothermic lah. They release heat. When you touch it, it feels a bit hot. Glow stick lah. You can use it in concert. Okay, in rave. But the strong ones, they use it in diving lah. All right, divers, they will carry a small one with them just in case they run out of light. All right, so anyway, you know what? I think I'm going to stop here. Next week, I shall finish this chapter for good. All right, as you can see, this is only a very simple chapter. All right, so anyway, thanks for coming, guys. Happy Thursday to you all. I will see you guys next week. All right, so take care. See you. Good night and bye-bye.